Proof by exhaustion. It's not so much that you sort of exhaust yourself by doing the question, but the point is that you need to sort of exhaust all the possibilities. Okay, so in question 1 here, it says prove that every odd integer, okay, between 2 and 26 is either prime or the product of two primes. Okay, so ideally set up like a table, okay, and you could see here I'm looking at the odd integers, of course, are the whole numbers, okay. So the odd integers between 2 and 26 then will be these which I've listed, yeah. Okay, so the smallest one will be 3 all the way up then to 25, and you just need to then go through each one systematically and show whether it's prime, okay, or confirm whether it's prime, or in this case the product of two primes. If you do that for all of them, then you proved by exhaustion okay, that the odd integers between 2 and 26 are either prime or the product of two primes. So for instance 3, well of course 3 is a prime number, isn't it? Okay, so we're okay there. Okay, 5 is also a prime number. Okay, 7 is also a prime number. Now 9, because we know 9 isn't a prime number, okay, so what we can do then is look at its prime factors, okay, and write it as a product of primes, yeah, if you remember the topic of prime factorization, okay, at GCSE. And if you think about here, well, the prime factors of 9 are just 3, aren't they? 3 is the only prime factor of 9, and you can do the product of 3, okay, and that will give you 9. So 3 times 3 is 9. 11, well 11's prime, isn't it? 13 is prime. 15 is not prime, okay? Again, that is the product, okay, of primes then, okay? And the prime factors of 15 are 3 and 5, so you can multiply 3 and 5 together, that gives you 15. 17 is prime. 19 is prime. Now 21 is not prime, okay, because 3 and 7 are prime factors of 21, but you can, of course, you can do 3 times 7, okay, that gives you 21. 23 is prime, okay. Now 25 is not prime, okay. It only has one prime factor, okay, and that's 5, okay, a bit like 9, isn't it? Because it's a square number and it's got one prime factor there, okay, of 5. Okay, so 5 times 5 there will give me 25. Okay, so have we proved by exhaustion that this is the case? It's either prime or the product of two primes. Well, yes, we have here, haven't we? These are primes. That's the product of two primes. Okay, they can be the same. That's not a problem. Prime. Now, it got me asking the question then, well, we proved it here now. Why have they said between 2 and 26? You know, what's wrong with 27 then? Okay, so maybe 27, it doesn't work. So when you actually check 27, so maybe we'll do this in brackets, because we don't need to do this, but when you check 27, well, 27 isn't prime. Okay, but if you think about 27, the prime factorization of that is 3 times 3 times 3, yeah? Well, that's the product of 3 primes, okay? So we've actually proved that for integers between 2 and 26, okay, if they are odd, then they are either prime numbers, okay, or the product of two primes. Okay, so we proved this by exhaustion.